By now, we know that the main purpose of programming is to solve problems, and to solve problems, we may need to use various arithmetic and logical operations in our programs. So it's always important that we have a good knowledge of all those operators that C supports, or at least those operators that we frequently use in our programs. In today's class, I will talk about arithmetic operators that C supports, and in our following classes, I will talk about other types of operators that we frequently use and which are important. So let's get started. Operators are used in programs to manipulate data and variables. So in our programs, we may see that we may have many calculations where we are directly using the data, or we may do those calculations based on the variables, and variables are those things through which we communicate with the memory locations where actually those data are saved or stored. That means those calculations play a very crucial or important role in our main logic of the program. So those operators also that we use in our program used to form significant part of the mathematical or logical expressions in our programs. And as I said, C supports a rich set of operators. In today's class, I will only talk about arithmetic operators. C supports 5 arithmetic operators. These are their symbols: plus, minus, then asterisk, front slash, and then percentage sign. And in the second column, we can see their meaning. And we all are familiar with this addition, subtraction, multiplication, and division. There is one more operation which is called in the language of programming modulo division. So modulo division is nothing but here we calculate basically the remainder part of any division, and that is only applicable when both the operands are integer. Suppose if one of the operands is 20 and the other operand is suppose 3. So if we perform the division, then in decimal we will have some value which will be 6 point something. But if suppose if we want to know the integer value of that quotient and remainder, then it will be what we know, that 6 3s are 18 and then 18 plus 2 20. So in integer the quotient value will be 6 and the remainder value will be how much? The remainder value will be 2. So if we perform integer operation that I will talk about very soon, then of this division between 20 and 3, the result will be 6, and of the modulo division the result will be 2. And which operation we are performing, based on that we will be getting our result definitely, and accordingly we will be using the operator also. So if both the operands are 20 and 3, and between these two values, these two operands, if we use this operator, then their result after execution of this program will be 6. And between the same operands, if we use this operator which is for modulo division or remainder, then their result will be after execution of the program 2. And this modulo division we cannot perform between two real operands. Real operands means the operands which will have float data. In C programming language, float, that means the values which will have decimal point. Integer division truncates any fractional part, that I have said also, that if we are performing integer division, then after division we will be getting only the integer value as a result and the fractional part will be truncated. Modulo division produces the remainder of an integer division that I have already talked about. Modulo division operator cannot be used in floating point data. This is an important information or important point that we have to always remember. C does not have any exponentiation operator. It has some library function by using that we can find the exponentiation value, but it does not have any exclusive operator for that operation. C supports 3 types of arithmetic operations: integer arithmetic operation, real arithmetic operation, and mixed arithmetic operation. So I will talk about all of them one by one. So first we will see integer arithmetic operation. When both the operands in a single arithmetic expression are integer, then that arithmetic operation is called integer arithmetic operation. Integer arithmetic always results an integer value, be it addition, subtraction, division, multiplication, or modulo division. Always the result will be integer. So accordingly, we need to use the correct data type for the output variable in which we want to store the result of that integer arithmetic operation. So to store the output result of any integer arithmetic operation, we should always use integer data type. Even if we use float double or long double, that will not give you any wrong output, but that there will be extra decimal point, and after decimal point, as per the data type, there will be the number of zeros, or those zeros after decimal point will be getting unnecessarily. So if we don't need them, then we should avoid them. Now we will go through a few examples. Suppose if one of the operands is 10 and the other operand has value 3. Now the first operation is addition, and from the simple logic of mathematics we know that that result will be 13. Then the result of subtraction will be 7. Then multiplication, it will be 30. And what about division? Since this is the division of two integer data, and it will, as output also, it will store integer data, so it will not store 3.33, rather it will store 3, and that 0.33, that fractional part, that will be truncated. And if we perform modulo division operation, then the remainder part, 3 3s are 9, and 9 plus 1 10, so that remainder, that will be stored as a result of modulo division, as I said. Now the next operation, where we have 4 operations: multiplication, division, subtraction, and addition, and we have 5 operands. Then how to perform this? In the previous slide we have already seen this table, where we, in the third and fourth column, we have seen the associativity and rank. There I haven't talked about. Now what is rank? Now in this type of expression where we have multiple operands, then which one to perform first? In classical mathematics also, that we have studied at school level, there also we have seen that there we have rule, and according to that rule we perform those operations. In programming language also we have that set of rules. So every operation is not performed at the same time parallelly. They have their own priority or precedence, and that is the concept of rank. So here, as we can see, that for addition and subtraction, their ranks are 4. For multiplication, division, and modulo division, their ranks are 3. So in C programming language, lower is the value of the rank, higher is the priority. In any arithmetic operation, if we have multiplication, division, modulo division along with addition and subtraction, then these operations will be performed before addition and subtraction. But again, there is a confusion that if in an expression we have all these multiplication, division, and modulo division, then which one we need to perform first? Because all of them have the same rank, 3. So in that case, the rule is that the operation or operand that we will be getting at the extreme left, that will be performed first, and then our processing will be moved towards right. So in C programming, this multiplication and division and modulo division, they will be executed from left to right, and that's what their associativity is. Even in case of addition and subtraction also, they are also executed from left to right. Now we will go back to this expression. So here we have all these 4 operands or operations. So if we look at this table, then we have multiplication and division, which has lower rank value. That means they have a higher precedence or higher priority. So multiplication and division will be performed before addition and subtraction. Then among multiplication and division, multiplication we are getting first. So that will be processed first or executed first, and then it will be followed by division. So if we manually calculate this, then it will be 3 6 are 18. Then we will have this division operation or operand, and then subtraction, and then addition. So multiplication is done, and over addition and subtraction, division has higher priority. So next division will be performed. So it will be 9, then minus 7, and then plus 4. Now we are left with only addition and subtraction, and addition and subtraction have the same rank. So we will go to the associativity. So they will be processed from left to right, and at the left side we have subtraction, so we will perform subtraction first, so 2, and then addition, so 4, and then the final result will be 6. Then we will take another example where again we have we have 5 operands that the integer arithmetic supports, so finally it will be 12. Now this is a simple C program where we are executing both the expressions that we have seen just now, and then we are printing their results. So as you can see, the output of the first expression is 6 that we have manually done, and the output of the second expression, same expression, the result is 12. So that also we have manually solved. Now we have seen division operation or integer division operation where the numerator is greater than the denominator. So what if the numerator is less than the denominator? Then what will happen in that case, in case of integer arithmetic division? So in that case, if both the operands are of same sign, then the result will be 0, because that is going to come in fraction and the whole fractional part will be truncated. So the result will be saved as 0 only. But if one of the operands is negative, numerator is less than denominator, and one of the operands is negative, then the result will be machine dependent. So that may show you 0 or that may show you 1 also. And in case of modulo division, the sign of the result is always the sign of the first operand. So this is also an important point that we need to remember. In this line, we are printing the result of a division where the numerator is less than denominator. It is showing, the result is showing 0. And in this line, in the last line, we are printing a result where we are basically performing the modulo division and both the operands are negative. And since the first operand is negative, so the result of that modulo division is also coming as negative, and that is coming as -3. Next type of arithmetic operation is real arithmetic operation. And real arithmetic operation is that operation where we have only real operands. So none of the operands will be integer. A real operand may have values either in decimal form or in exponential form. Final result may be an approximation of the correct result. Definitely, if it is a infinite decimal number, then somewhere it has to be truncated. And which result it will store finally, that depends on what data type we are using for the output variable. So if it is float, then it will, after decimal point, it will show you, or it will store 6 digits. If it is double, then after decimal point it will store only 15 digits, and then rest of the digits it will truncate. So always that result will be an approximation of the correct result. Modulo division is not permitted, as I said earlier, in case of real arithmetic. Now this is an example where we have taken a as real value, as you can see, that is 10.45, and b also is a real operand 3.25. and now if we perform addition, that we can do easily, and this is the result, subtraction, multiplication, and this is the result of division. And in this type of division where both the operands are real, the result will be also real or decimal. So this time it will not be integer. So it will not truncate the whole decimal part. It will only truncate the digits that it cannot accommodate as per the data type that we have used. Now this is another example where one of the operands we have taken as negative. The same values, only a is negative here. Accordingly, we are getting the result of addition, subtraction, multiplication, and also division. And this is a simple C program that has been written for the second set of real operands or real arithmetic operations. And here we are performing all these operations, addition, subtraction, multiplication, division. These are their results, which is same as the result that we have obtained manually. Now the next type of arithmetic operation is mixed mode arithmetic, where one of the operands will be real and the other operand will be integer. So far for integer arithmetic, we have seen both the operands or all the operands are integer. In case of real arithmetic, all the operands are real. And in case of mixed mode, if suppose we are performing between two operands, then one of them will be integer and the other one will be real. So if any arithmetic operation or expression If at least one of the operands is real and rest of the operands are integer, then it will be called as mixed mode arithmetic operation. Since in mixed mode arithmetic, at least one of the operands will be real, so modulo operator again is not permitted in this case. And this is an example where we are taking one of the operands as integer and the other operand as float or real, and this is the result of their addition, subtraction, and here we are changing the values. Value wise they are same, but the second operand we are taking as negative, and if we perform multiplication, then manually we will be getting this value, and this is the result of division operation. And this is a simple program that has been written for mixed mode arithmetic operations, and this is their corresponding results. The same values we have used here as input, so same results we are getting as output also. So this was all about arithmetic operations and arithmetic operators. I hope these calculations and these operations are clear to you. In the next class, I will talk about relational and logical operators. Till then, stay safe and stay healthy. Thank you.